Excellent. And we are back live once again. Oh, we're in May. The rest of the school year, it's going to be weird. We have approximately 6.5 weeks until the end of the school year. Hopefully you can see that right here. I filled in like May and June. I don't know, you guys you got that 5-day weekend at the end of May, all sorts of weird stuff. It's going to fly by like crazy. And then like this is the week of final exams. I got to ask, not you guys, I got to ask my supervisor, but I have to ask my supervisor or whatever about final exams in these classes, because I do have a fair number of seniors, and seniors, obviously, they're obligated to take their exams early. So does that mean the rest of you will get to take it early? I don't know. I guess we will find out when the time is appropriate. For those of you in the live stream, if you would leave a comment in the chat, that would be absolutely wonderful. That would be divine. And then I will remind you of that later as well. I'm actually bringing that up on my phone right now so that I can double check that live chat. There they are. I can see the 2 comments that are left so far. So if you're joining us, please leave that comment. Okay. Number 1, we started doing remediation enrichment last week. We will continue that in the last portion of today's class from noon up to the end. I do have something lined up for that, and I will fill you in on that when we get there. Number 2, if you did not get that enrichment remediation thing done from last week, you need to get that done. It will count in Genesis. So you will have an opportunity perhaps today to wrap that up, but I'll talk about that when I get there. Wednesday. I may have mentioned this before, but I want to mention it to you again. Wednesday, I will not be here. I'm going to be proctoring a AP test somewhere near the education building. This is mainly for those of you who are in the live stream right now. Wednesday, I will not be here, and there will not be a live stream, but I will have a different procedure for attendance. You guys here today do not have to worry about that, because whoever the substitute is going to take care of your attendance. But for those of you that are in the live stream, I will have a different procedure for that. So please make sure that you're paying attention on Wednesday at class time. Oh yeah, and Wednesday's a half day for you guys, right? So I already forgot the times. It's like 9:28 to 10:28, give or take, somewhere in that range. I'll put reminders in Google Classroom. As for today, I want to start off with a little bit of practice on quizzes. Practice on quizzes, a practice on the graphing that we've been doing. Now, obviously, you have your Chromebooks, you have your calculators that are on your Chromebooks as well. So those are fair game to be used. It is a practice. I will be eventually assigning an assessment on this stuff, but I will fill you in on that when the time is appropriate. This is a practice. After said practice, I have other things that I want to do by hand that I am going to be giving you. You'll see that when the time comes. And then we will wrap up with that enrichment remediation period at the end. Oh, happy day. Okay, let me bring up the code that you need in order to do said practice quizzes that you're all logged on for. Chapow and chapow. There is the code that you need at the top. I will type that into the live chat, 420380. Oh, my live chat there is not there. It's on my phone, actually. There we go. Make sure you're getting logged into that as quickly as humanly possible. That would be wonderful. Come on, YouTube, do your thing here. Boom, 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 and boom. And then I can hear all of them popping in. There we go. So it should be 420384. Boom. There's the code in the chat. Just in case you can't see it, you are to go to joinmyquiz.com. Join that quiz. We'll get this started in a few moments. I just want to make sure everyone has the opportunity to log in. This will be on graphing rational functions. It's going to be using a lot of the definitions that we've been doing in class for the past several class periods. You can obviously, like I said, use that graphing calculator. It's fair game. But let's see what happens with this thing once everyone kind of gets logged on there. How many I have here? I have 5, 6, 7, 8. I have 8 of you in class. Yes. Real quick, you logged on? Yeah. We might get started before you get back, but that might only be like 30 seconds. So. Waiting for people to log on. It's like the people in the chat, they're just like, yep, I'm just going to check out for the rest of the class period. That's what people in the chat are saying. Well, not all of them, of course, but. Oh. I say that as another one joins. Okay. I'm going to get started in a few moments, just giving them an opportunity. And as a reminder, before we get this thing started, for those of you in the chat, if you have not left a comment, please make sure that you do so. I can see the 1, 2, 3, 4, 5, 6, 7 of you that have left a comment so far. If after we click start, you have not joined yet, you can still join, and I encourage you to do so, obviously, since you are in my class at the moment. Let's get this thing rolling. The code will be at the top of the screen. Oh, come on, this thing. Over here. There. Remember, this is just a practice. This is nothing more than a practice. This does not count against you. Did the questions work for you? Yeah. Okay.
For those that are wrapping this up, I'm going to give you another minute or two to kind of do that. And then I'll let you know what we're going to be doing next. We're just about to wrap it up in about a minute. The thing. It's interesting. I'm going to click the stop button in a moment as I walk over here. But it's very interesting that the percentages started off kind of low. Like you guys were at like 15, 20%. And by the end, you guys had like, as a class, built it up over 43%. That's pretty solid. A solid comeback. Let's talk about some of these questions. Let me end this thing right here. Oh, I want to see if he gets the next one now. Nah, I'll end it there. Click. So let me take a look at this. Bring this over here. Turn it over here. There we go. I'm not going to take a look at all of the questions on this thing. I do have other questions that I want to talk about, but I want to look at the questions that gave us the most trouble. For example, on a problem like this. Now, I'm going to remind you of some of these ideals when we get to our notes in a little bit. I'm going to remind you of some of these ideals and things that we need to know in order to get these questions correct. But it wants to know, what is the horizontal asymptote? Now,
There are 3 cases for horizontal asymptote. And I'm going to remind you in shorthand of what they are in our notes. But the 3 cases are about the degree of the top and bottom of the fraction. If the degrees are equal, if the top is larger, if the bottom is larger. Now, again, this was more of a notes situation. But looking in our notes, if the denominator had the larger degree, then the horizontal asymptote would be absolutely, bar none, y equals 0. I can see why most people would have picked 1/3 because they saw the 1 and the 3, but that case only works if the degrees of the top and bottom of the fraction are equal to one another. And I can see most people just kind of looked at those numbers, the 1 and the 3, and they divided them. And I know that for a fact because, well, not only did they pick 1/3, but look at the average time spent on the question. That's how, oh, 1/3. Got it. Moving on. Oh, got it wrong. Because we're just trying to get questions done quickly. On this one, interesting. Well, the question's kind of small right there. But the degree of the top and bottom of that problem, see, it's a little bit larger right there. You can see it on the side right here. The degree of this one has a 1 on top and a 1 on bottom. Those are equal. We'll talk about those. In fact, I might use a couple of these examples in our notes. But yeah, the answer should have been 1 for that one. And then what about this one right here? The horizontal asymptote equals 0 when? And then, yeah, that had to be the definition that I gave you. I'm just kind of seeing what I'm going to be covering in a few moments. Vertical asymptote, remind you of that. What are all of the asymptotes of this one right here? This one actually had 3 asymptotes. Oh, interesting. 5 people chose the first option, which was partially correct, but not all the way. Huh, that's interesting. And then they wanted to know the horizontal of that. Interesting. Okay. What I need from you, if you do not already have them out, I'm going to need those notebooks out and open. Let's get this thing moving. Doing these quizzes is incredibly helpful for me to see what it is that we need to be focusing our attention on. I have several things lined up for this practice that I want to do today. It's not about teaching brand new stuff today. It is about practicing what we have already covered. Consider that like not an introduction, but kind of a warm-up to the class. First, the horizontal asymptote, or the HA, has 3 cases. It has 3 cases. You have to look at the degree of the numerator versus the degree of the denominator. Need to determine degrees of top and bottom of fraction. Again, that degree is going to be the largest exponent for the top versus the largest exponent on the bottom. And I have several examples, and I'm going to pull up a couple examples from that quizzes in a moment. But those 3 cases, let me split it up like this. Basically, if they are equal versus the top is larger versus the bottom is larger. These are the 3 cases right here. Either the degrees are equal, the top is larger, or the bottom is larger. If they are equal, that's where you would divide leading coefficients. This is where you would divide the leading coefficients. And I, again, will throw up a couple of examples like that from the quizzes, a couple of the questions that we peeked at before we jump to this. If the bottom is larger, and notice I'm skipping over here to where the bottom is larger. If the bottom part of the fraction has a larger degree, then y equals 0 is always going to be the horizontal asymptote. Always. No ifs, ands, or buts about it. If the top has a larger degree, there is no horizontal asymptote, but there is a slant asymptote. Which the slant asymptote, that's not as common. It's not as common, but it is definitely a possibility. Basically, the asymptote is not horizontal, it's slanted to the side. I've also heard it referred to as an oblique asymptote. I am not a fan of calling it an oblique asymptote, but I've heard some people call it that, other math teachers. I just call it a slant because it's literally just slanted for the most part. These are the three cases for horizontal asymptotes. I want to take a look at those last couple of questions on the quizzes to kind of show that. So I'm going to bring this back in a moment. I'm just going to slide this upwards. And I'm going to bring back a couple examples directly from that quizzes. Here we go. There we go. And there's the first example right there. I'll change my screen over in a moment. 3x squared plus 3x minus 18. Chapow. There it is. There's that example right there. Looking at the top versus the bottom, I need you to recognize the fact that there is no variable in the top. There's no variable in the top of the fraction. None. And since there is no variable in the top of the fraction, the degree of the top of that fraction is technically 0. The degree of the top here is equal to 0, whereas the degree on the bottom is equal to 2. There is no variable on the top, so the degree is 0. It's x to the 0 power. But on the bottom, the largest exponent that I have on a variable is x squared, thus the degree is 2. That falls into this category right here, the third category, that the bottom is larger. The bottom has a larger degree. As a result, the horizontal asymptote has to be y equals 0. It just has to be. We need to be able to look at the degrees. I have several examples that I'm going to be giving you on a worksheet today. For those of you in the live stream, I'm going to be giving you the PDF of it, of course. But we need to recognize what those degrees are. Let me look up the next example here. There we go. It was y equals x plus 5 over x minus 6. I'll slide that up in a moment. There we go. That example from the quizzes, I believe there were multiple questions with that. I'll talk about those details. Let me just double check, because, yeah, I think it was here and there. There's just a couple of questions then. Yep, a couple of questions from that quizzes. And they wanted to know the horizontal asymptote. Well, the degree of the top is 1, and the degree of the bottom is 1. The degree is 1, and the degree is 1. This is an equals case. There are 3 cases for determining the horizontal asymptote. If the degrees are equal, then yes, you divide the leading coefficients. The horizontal asymptote is y equals 1 over 1. And yes, that can be simplified. We'd simplify that. I'm just leaving it there temporarily. If the degrees are equal, we would have to do something like that to determine the horizontal asymptote. In fact, let me go back. I'm not going to put this one in my notes, but I am going to go back to the quizzes real quick. Click to this example right here. Click. They want to know the horizontal asymptote. I'll write that one a bit larger on the board, actually. So I don't know why they have that thing so small right there. But this was 2x plus 6 over x plus 1. This is a situation in which, again, the degree versus the degree, they are equal to one another, the largest exponent on those variables. Leading coefficients now are 2 divided by 1, which is why that answer was y equals 2. I can see why, again, a lot of people would immediately be like 6, because 6 over 1. But again, that's not what the definition said. The definition was not talking about the constants. The definition was talking about the leading coefficient. So we do need to distinguish that when we are working through these problems. Let me take a look at one more from the quizzes that I can put into my notes here. I don't want to draw that one right. Well, actually, yeah, we'll go back to that one then. Okay, same example. Same example, this one right here. I'll just continue it. So now, reminder to find vertical asymptote, or the VA, set denominator equal to 0 and solve. Literally those words, those directions. I'm going to do it for this example in a moment. To find the vertical asymptote, you need to set the denominator equal to 0 and solve. Now, I'm going to check real quick in a moment. I just want to visually see on the quizzes what most of you picked for this particular example. I'll flip back to this page in a moment. Let's see. Okay, it was split. It was split between -5, 6, and -6. And then one person picked 5. I can see why. I can see why. A lot of people, well, 3 people, I should say, picked -5 because, well, if you plug -5 in, you get a 0 in the top. But that's not what the definition says. I can see why they picked -6 because they see the -6 in the denominator, but that's not what the definition says. The definition says set the entire denominator, set the denominator equal to 0 and solve, which is why your vertical asymptote was +6 for this particular problem. We got to read the definition. We have to compare that definition against what the question is actually showing. Okay. Here's what I want to do. I would strongly suggest that if you do have your Chromebook still open, keep them open so that you can utilize the calculator in those Chromebooks. If you don't have them open, well, again, I strongly suggest for the calculator's sake. But I do have some examples that I want you to try out. Yes. For those of you in the live chat, I have a PDF of these problems available for you that I'm going to post into the Google Classroom literally right now. There it is. It just got posted. A PDF for today. And if you open it, it will show you the exact problems that we're working on. Now, it's not required for you to print this out. But if you did print this out, then you would have a nice little XY grid for you to graph these things on, which would be phenomenal. There it is. But this is the practice that I would like to do today. Now, if you notice, for these problems, the directions do say factor if needed. We will deal with that when we get there. But for right now, I want to do some of these things together. But again, I want you to be able to try and do parts of these on your own. That's why you have the calculator open. You have the calculator open. You have the ability to use the calculator on your Chromebook. You have the ability to use Desmos, if need be, to be able to figure out what the heck these things look like. But I want you to be able to identify some of the things that they are asking for in the directions. You are to clearly identify the asymptotes, x-intercepts, holes, which I have not shown you yet how to find those. I will today. You are to create a table of values, which you can get directly from the calculator. And then I want you to sketch the graph. Now, when I say sketch the graph, I want those asymptotes in the proper location. I want the table of values and those points in the proper location. And I want that smooth curve to reflect exactly what this thing is supposed to look like. So you guys have this worksheet. For those of you at home, you have the PDF available to you. Let's see what we got here. So I'm going to bring this paper up here. There we go. I'll zoom in. First thing that I would like to do, and I'm going to zoom in on this, and I'm going to suggest that you do the same thing, whether you're putting these on your notes or directly on this worksheet. You can put this directly on the worksheet. I want you to be able to identify the case for the horizontal asymptote. Now, for the horizontal asymptote, oh no, the degrees are equal. The degree of the top of this fraction versus the degree of the bottom of this fraction, they are equal to one another. It's actually 1 over 1. I'll zoom in a little more right there. And because of that, because of the fact that the degrees are equal, this is the case where you would take the leading coefficients, not the 2 and the -1, but the +3 and the +1. You would take the leading coefficients and divide them to get for yourself a horizontal asymptote. It's y equals 3, or 3 over 1. But again, it's a 3. It simplifies. That would be one of your first steps. One of your first steps. Again, on the next problem, we may have to do something slightly different. We'll deal with that when we get there. The next thing I would have you do is I would have you identify, if any, a vertical asymptote. To identify that vertical asymptote, you set that denominator equal to 0. Set the denominator equal to 0, and you solve. There's going to be a vertical asymptote at x equals 1. Again, these are according to the directions. I have not typed this into a graphing calculator. I have not seen what this thing actually looks like, but you can identify all of these things without typing it into a computer, without doing any of that stuff. You can figure out what these asymptotes are supposed to be. You can figure out what the x-intercepts are supposed to be. Oh, that was a direction I haven't talked about today. You can identify an x-intercept by taking the numerator and setting it equal to 0 and solving. This can come in handy especially if that x-intercept is not going to be in my table of values. And this one won't. This x-intercept won't be in my table of values on the computer. But because I'm finding it right here, I know exactly where it is supposed to be. If you solve this, you're going to get the fraction negative 2/3. This particular problem does not have any holes. I'm going to have to go back to our notes to give you the definition of holes, possibly on the next problem. We'll see when we get there. But now I am ready for a table of values. This is where your computers are going to come in handy. Desmos can help, but at the same time, the calculators that are on your Chromebooks can help as well. Obviously, if you had a graphing calculator, a handheld graphing calculator, you could do the exact same thing. Let me reset this real quick. There we go. Go to your y equals key. You go to your y equals key, you type in 3x plus 2, put it in parentheses, divided by parentheses, x minus 1, close parentheses. Make sure that you can type it in correctly. You type that sucker in correctly, and then I'm going to go to second graph. If you go second graph, you can see the exact table of values that I need. I just need a couple of points to the left of the error and to the right of the error. The error is going to be my vertical asymptote. The error is going to be my vertical asymptote. Sometimes the error doesn't show up in the table of values. Sometimes it doesn't. And if it doesn't, you have to recognize where it occurs. I'm going to show you. In this case, I'm going to actually write in the error. There we go. Click. Make that larger. Click. There we go. This is all I'm writing down for my table of values. Right here. This is all that I'm writing down for my table of values. That's legitimately all I need for my table of values. I don't even need to write the error there. I'm writing the error there because I want to. The error is in my, well, according to my work from earlier, is my vertical asymptote. I'm just going to label it as my vertical asymptote. VA, VA. Now I'm ready to draw this thing. Now, obviously, yes, you're supposed to sketch this thing, but I want accuracy. The accuracy that I want are these points and the proper location of the asymptotes. My vertical asymptote, I'm going to be putting directly on this graph. Now, again, like I said, if you're in the live chat and you can't print this out right now, of course, you can draw this on paper, but it's a little bit easier when the grid is already there for you. Here's my horizontal asymptote. I'm putting them in the proper location. Y equals 3, x equals 1. Then I can start plotting these points. Well, I know negative 2/3 is my x-intercept. I'm just going to start putting some points right there. Negative 1.5. There we go. 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. 3 and 5.5. 3, 4, 5.5. That's all that I need to draw this thing. This is all that I need to draw this thing. You get a couple of points to the left, a couple of points to the right of where that vertical asymptote is, and you can draw this sucker out. In fact, let me get a... I think I have to find... Yeah, there we go. I hope this shows... Oh, no, that's an expo marker. There we go. See if this works. I don't know if this will work that well. That show up? Yeah, kind of showed up. But you're going to be flatlining against these asymptotes. You are going to be flatlining against these asymptotes as best you can. There's my curve. I'm going to go back to the graphing calculator. I want to see what the calculator said it was supposed to look like. Let me see, calculator. Graph. Nice. That looks pretty close to what I got. But that's what you're looking for. You're looking to identify all of those little pieces and then draw this sucker out. Let's take a look at number 2. We're going to do number 2 together as well. Because again, today is all about practice on this stuff. Let me zoom in on the equation. This is the problem that we need to factor. This is a problem where we need to factor first. Moving forward from now, it would be a great idea if factoring would be the first thing that we did. And you'll see that moving forward. The top of the fraction doesn't change. But then the bottom of the fraction, just for the sake of argument, turns into this. X minus 3, x plus 1. I need to ask you an important question. I need to ask you a very, very important question. Does anything cancel out? This is a very important question. And then depending on your answer, then I have a response to that. But does anything cancel out from top to bottom? You're shaking your head no. I agree. No. Here's the direct consequence of that. Ready? Nothing cancels. There are no holes. Now, I have not given you the definition as to what a hole is yet. I've shown you where a hole could actually happen last class period, but I said I'll talk more about that next time. A hole will occur if something ends up canceling from the top to bottom of the fraction. But since nothing canceled, you don't have to worry about it. There are no holes for this problem. After we do this example, I'm going to give you the definition of what a hole is. I'll give you that definition. But let's finish this one out first. First and foremost, horizontal asymptote. You're aha. I look back at the problem. The degree is 1 on top and 2 on bottom. You tell me now. If the degree on top is 1 and the degree on bottom is 2, what is my horizontal asymptote? This one will have one. It's y equals what? This one will have a horizontal asymptote. Separate these things out here. There we go. Now, I haven't written the answer yet. I want to type this into my calculator. Let's take a look. Because if you can't figure it out by the equation, you could at the very least figure it out visually. About a horizontal asymptote. Let me bring this thing in right here. Parentheses, x plus 3, close parentheses, divided by parentheses. I would strongly suggest typing in the original equation. There we go. There's my equation right there. Let's take a look at the graph. What the heck is this thing doing in a horizontal direction? Doing a little weird shimmy down there. That's weird. I'll have to take a look at that, actually. Hold on. Trace -5. Nope, that's a minus. Trace -5. Ba-pow. Oh, yeah, look at that. It actually does dip below and then come back up to it. That's really weird. Oh, well. Just for the sake of argument. It has a horizontal asymptote of 0. The bottom is larger. The bottom has a larger degree. And because the bottom has a larger degree, the horizontal asymptote is automatically y equals 0. No ifs, ands, or buts about it. You don't have to worry about anything. The bottom is larger. Let's deal with the vertical asymptote. Now, the vertical asymptote, you are to set the denominator equal to 0. Well, if you're going to set the denominator equal to 0, it would be in your best interest to set the factored form equal to 0. Because then, as we've done since the beginning of the year, you can get your solutions. Those two numbers are your vertical asymptotes. Those two numbers are your vertical asymptotes. Your x-intercept, you set the numerator equal to 0. It's going to be the same thing over and over again for a lot of these problems. Find the asymptotes, find the intercepts, find the table of values. You get an x-intercept at -3. This is the process that I would have you go through. Factor, and I'll give you the definition of a hole in a moment. Find me the asymptotes. Find me the x-intercept. Find me the table of values. It's the same procedure over and over again for these problems. In fact, I already have it typed into my y equals key. Again, this is something that you would need to know how to do. Make sure you know how to access a table of values. Make sure you know how to type this in correctly in the y equals key on your Chromebooks. This is why I said to have them open. Make sure you know how to type that in correctly. If you go second graph, there are multiple errors, but that is okay. It doesn't matter that there are multiple errors. There are multiple vertical asymptotes. I'm going to go a couple of points to the left and a couple of points to the right of all of those errors. Oh, this one has a very interesting middle portion that I have to talk about. I'll show you what I wrote down in a moment. There we go. Click. That's what I wrote down for my table of values right there. Give you a moment to kind of copy that. This middle portion is going to be interesting. This middle portion is going to be very interesting. I'm going to plot all of those points, and then we're going to talk about what the heck this graph is supposed to look like. Again, you don't have to calculate any of this stuff. As long as you know how to type it into your y equals key, you can get that table of values. But you have to type it in correctly. You need to have the practice with typing them in correctly. Otherwise, you're not going to get the correct table of values. Let me plot my y-intercept, my asymptotes. This one has a horizontal asymptote right on the x-axis. I'm going to try my best right here to kind of do that thing justice. I'm embellishing it right on top of the axes. It has two vertical asymptotes. I would strongly suggest, again, Putting them in very carefully. Don't try to rush this. As these things, if you want to be precise, take a little bit of time. I can start plotting these points in, like my x-intercept right here, at -3, 0. At -2.2, I'll talk about what that looks like in a moment. At 0, -1. At 1, -1. And at 2, -1 and change down here. Oh, snap. We're going to have to talk about what the heck that looks like in a moment. 4 and 1.4. And 5 and 2/3 right there. These are where all of my points are, according to that table of values. We're going to take a look at the graph to kind of confirm what shape all of these will take. Let me see here. I'm going to flip back real quick. Ba-bow. Oh, ba-bow. There we go. Look at the shape that the graph gives you. Look at where all of the curves are. This is going to inform what you end up drawing. This is going to be very helpful. Obviously, all of the points that we picked, all of the asymptotes that we found, they are where they said they were going to be. But now it is our job to kind of draw this thing out. It's going to flatline down here. It's going to flatline up against the vertical. According to what I just saw on the calculator, it's going to do some kind of flatlining up here and flatlining down there. In the middle, this is a weird little thing right here. Thankfully, the calculator was able to give me a little bit of insight into what happens, but it looks something like that. The calculator will be your best friend when it comes to graphing these accurately. Most of the time, it's just going to be identifying where things are. Where are these asymptotes? What's the justification behind these asymptotes? Is there a hole that exists? How do you determine the x-intercept? Do things cancel out if you factored them? These are the things that you're going to have to do when it comes to these problems. Okay. This worksheet. We will work on this worksheet some more next class as we wrap up graphing. We will have, actually no, Wednesday will be your next class, so you're going to have practice on graphing on Wednesday. Yeah, you'll have practice on graphing on Wednesday. I'll have something prepared for you because I won't be here. And I will have to give you the definition of a whole different ways because I want to get to this remediation enrichment thing in a moment. Okay. Again, keep the Chromebooks open. I do apologize. I keep telling you, hey, Chromebooks, leave them open. I have not told you to put them away just yet, simply because you will need them for the next portion of class. The intervention period. Yay. Fantastic. Woo. Awesome. I can hear everyone being so excited for the intervention. Are you guys doing this in other classes too, like English and history? Only English? Not like history or science or anything like that? All right. Do they have you doing like stupid stuff in English too? Yeah. Notice the disdain in my voice, you know. Anyway. Here's what I'm going to say. And this is important directions for all of you and for all of you online as well. Last class, I assigned you an enrichment remediation dependent upon the email that I sent you right about here. I gave you this thing right here. And I said to follow the instructions on my email from April 29th. That still stands. That is still fair game. I am combining that. With today's brief activity. So regardless of whether or not you were enrichment or remediation, I have a short, and I want to emphasize short assignment for you. That's not us. They haven't fixed the bells yet. The short assignment that I have for you is this. There is a video that you are going to watch. It's some guy talking. It's roughly 7 minutes or so. There are 4 questions, just 4, that you are going to have to complete. I would like these done. Now, I say short because it's literally just a video and 4 questions. Yes, it is just today a video and 4 questions. If you can get them done quickly, correctly, that would be important to me. Once you get these done, with the time that you have left, you need to finish the remediation enrichment from last week if you did not already. I am going to count last week's remediation enrichment and today's remediation enrichment as a single thing. So if you did turn in the remediation enrichment already for last week, great, good for you. You're ahead of the curve. I would like you to resubmit this after you get it done today. For those of you who did not get last week done, you need to get it done. I have various things I need you to get done. There is a homework that I did assign you. Where is it? Right here on page 558, which I did include. I did include the PDF of the questions themselves, but I had directions that I wanted you to find. All of the directions from that homework are based on things that we've been doing in class with graphing. And in fact, pretty much almost everything that we did today on paper is on that homework. So this is your task. What I'm going to do is I am going to update the assignment from last Thursday, and I am going to put in the slideshow of this thing right here. Here we go. Update to this assignment is the attached Google Slides. I'm changing the due date as well. I'm going to make the due date Thursday at 8 a.m. Save. There it is right there. So let me put the update here. Update for 429 enrichment/remediation. Besides the email I sent you, there is now an attached Google slide. You are to watch the video, complete the 4 problems, attach your results. That is due Thursday, the 5th. Not the 5th, I'm sorry. Thursday's the 6th, right? Okay, nobody knows. Thursday the 6th. Email me if you have questions. Post. Boom. So right now, for the next 20 minutes, you are to be working on one of several things. Number 1, that 4-question Google slide that I just attached to the thing. Number 2, the remediation from last week, which should have already been done, but obviously if you didn't get it done, make sure you get it done. Or number 3, the homework that I assigned you last week on graphing these rational functions. Please take the next 20 minutes and be working on one of those 3 things. Use your time wisely. Again, just a reminder for those of you in the chat, I did see the last couple of comments that came in. If you did not leave a comment in the chat, please make sure that you do so. that kind of day. Yeah, but technically it rings at 22. I don't know why the bell schedule is off and no one's bothered fixing it. So just watch. Right now the clock is about to strike 21, and then at 22 it'll go off. So, like I said, for those of you in the live chat, for those of you here today, you have my assignments basically. Just a reminder, I won't see you until Friday because I will be out Wednesday proctoring an AP exam. But yeah, you have a half day anyway. But the assignment will be in Google Classroom for you to complete. So please make sure you are logging on to Google Classroom, especially those in the live stream, because I do need to take that proper attendance. I will leave the live stream open just for a few more, moments per se, I guess, just in case you have not made that comment. So please make sure that you do, and that would be phenomenal. But otherwise, we'll see you next time. There we go. Just watch. It'll ring in approximately 15 seconds.